Hello, everyone. So we're going to move into the section number 2 in Unit 1. Under this section, we are going to talk about vectors and scalars. And also we're going to discuss a little bit about how to add two vectors and how we're going to use the graphical method, how we're going to use the analytical method to add vectors. And also we're going to discuss about the physical quantities such as distance, displacement, velocities, acceleration. And in addition to that, we're going to move into the very specific problem that when the object is in constant acceleration motion, how we're going to solve that kind of problem by using the free fall motion. And then in addition to that, I'm going to talk about little more information about how do you describe the motion of the objects by using graphical representation. So those will be the parts that we plan to discuss in this chapter or this section. And your textbook will be, section on the textbook will be chapter 2 and 3 together. Again, this textbook is not assigned for your class, but we're going to basically learn the conceptual parts only from the chapter 2 and 3 for this section. Okay, so now let's move into the presentation. So first thing is understanding what is the vector and the scalar is. So vector is some quantity that you need to explain by using the magnitude and the direction. Simple example you can think is that if you're going to say my velocity of my car is 15 kilometers per hour. So now when you say that, that does not have any meaning unless you explain that I have the velocity of the car 15 kilometers per hour, but north direction. So, or you can say you apply the force 5 newtons. Then backup question will come up with which direction you apply the 5 Newton force. So that kind of quantities, we call it as vectors because you need to mention the direction and the magnitude both, right? So simple examples that we're going to discuss will be displacement, velocity, and acceleration in this section. And then scalar is a quantity that you can just explain by using magnitude. As a simple example, you can say temperature is 20 centigrade. There is no direction for that kind of quantities. Those we call it as scalar. So now vectors basically represented by using a line with the arrowhead. That distance of the line is the basically magnitude of the vector, right? So as a simple example, from here to here, this length, we call it as magnitude. And this arrowhead is the direction. So now representation of the vectors, different textbook use different symbols. So usually bold letter is the symbol that many textbook use, and that's the symbol I'm planning to use. And in addition to that, A to B is another way of representing, and some people just use the notation with the arrowhead on the top of the letter, but those are just notations. That's to represent the vector. But important thing is this vector, this end we call it as the tail, and this end we call as the head of the vector, right? So now it's very simple that if you have vectors, if you need to find the net vector that combine of these vectors, we call it as the resultant vector. That means we're going to talk about adding of vectors. Okay, simple example, if you have 8 kilometers this direction, and if I have 6 kilometers in the same direction, then your net vector, we call it as the resultant vector, that will be 8 and 6 together will give you the 14 kilometers. They are in the same direction, you can directly add them. But if you have 8 to the right and 6 to the left, and then you have the difference between these two, that will be 8 minus 6. That will give you the two resultant vector. So now this is very simple, that when we have the vectors in one direction, you need to add or subtract, right? But vectors are not always in the one dimension. They will be in different direction. If I have two vectors, one is in this direction, whatever vector v1 is, and there is another vector v2 is. So now what the resultant of these two, to identify that, first method that we are going to talk is the graphical method. Graphical method, or another way, it called it as tail to head method. So that means you're going to start from the one vector, start from tail and draw it tail to head. You take the ruler and whichever v1 number is, take that much of centimeters, and then you're going to draw that vector. And then take the protractor and measure what angle is it, and measure the distance and draw your second vector after ending of first vector following tail to head. So now after you do all the vectors drawing, then you're going to connect your initial to final point by using arrowhead pointing or ending at final point. That will give you the resultant vector. That is, we call it as graphical method or tail to head method, right? But in class, we are not able to do the graphical method since we don't have the rulers, we don't have the instruments that we can perfectly draw the vectors. So because of that, we're going to use the adding vectors by using component method, or the algebraic method or analytical method is the next one, right? First thing is we need to identify what is the component method means. So what is the components means? Okay, simple example is, if I have a vector, v vector in some direction. So now this vector, I will be able to project into my x direction. Projection of this vector towards x direction, we call it as x component, right? Projection of this vector into y direction, we call it as the y component. That means this vector I can represent this way, or else I will be able to represent by using two vectors which are perpendicular to each other. These two vectors, we call it as component, right? So now if I have v vector, x component, we call it as the v of x, and y component, we call it as the v of y, right? So these two vectors are perpendicular to each other. So now here we need to understand a little bit about the how to write the x and y components by using trigonometry. So we'll say, simple example I had earlier, this is my v vector is, right? So now I mentioned that we can write x and y component of these two vectors. I'm going to draw the parallelogram, and then I will have this part, because it's point in x direction, because of that, that is the x component of v vector, right? And then y component of v vector will be this one. This is v of y, right? Let's say this angle is theta. So now this is the parallelogram. Parallelogram means basically these opposite sides are equal to each other, right? And also in this case, since these are perpendicular to each other, they are in 90 degrees. So now how do you write the Vx, right? So you have, we'll say I know V, and then I know the angle theta, then I need to write the adjacent of the your right angle. So now it's very important that you know how to write this Vx and Vy by you in terms of v and theta. That means your cosine of theta in trigonometric function, you will be able to write by using adjacent divided by the hypotenuse, right? And similarly, sine of theta will be opposite over hypotenuse, right? So after you know this step, you don't want to keep writing these things, because you can do by cross multiplication in here, you can say V times cosine of theta is your Vx, right? And V times sine of theta is your Y component of the vector, right? So now X component and Y component, how you take, it is not always cosine of V, theta of V, but Vx is, if Vx is adjacent, then that will be hypotenuse times the cosine of theta. If Vx is your opposite, then it will be V times sine of theta, right? So that's simple. So now, as a simple example, if I have, we'll say I have 100 meters vector. So now if I ask you to write your X component of this vector and Y component of this vector, if your angle is 45 degrees, we'll say this one is 45 degrees, right? So now this is your X component and this is your Y component. How I write the X component will be, this is 45, we definitely know this is also 45, then this is 100 times cosine of 45, and this is 100 times sine of 45. Since it is 45 degrees, your rectangle will turn into a square in this case. Then your all the sides are equal to each other. Cosine 45 and sine 45 are the same, right? So that's the way that you need to write X and Y component. If it is 30 degrees, then you know you will get the rectangular shape. Then you need to write your X and Y components. Okay. Okay, so now adding of vectors. After you know your components, now we're going to do a little different or opposite way. So now if I have two vectors perpendicular to each other, what we did earlier, we had the one vector, we write the X projection and Y projection. Now we're going to do, we have X projection and Y projection. We're going to write the net or resultant vector. To do that, you can easily use your favorite theorem that you have learned in your elementary school. So Pythagorean theorem, right? So what that means? So if you know X component and Y component, how do you find this hypotenuse? So that is the solution for your resultant vector. Now V will be equal Vx to the power 2 plus Vy to the power 2 and root of that. That is, we call it as the resultant. Now, whenever we say any quantity that is a vector, we need to give the direction also, right? I don't want to ask the direction. You are responsible for giving that because you are talking about the vectors. Now, to find the direction, you can write tangent of theta equal opposite divide by adjacent. So that will be this, and then you need to find the theta by taking tangent inverse. Then after you provide these two answers, that will be the resultant vector of Vx and Vy. So now this Pythagorean theorem is working when you have two vectors only and they are perpendicular to each other. If there are more vectors, you need to convert or you need to build them up into two vectors, and then you're going to use the Pythagorean theorem. Other than that, Pythagorean theorem itself will work for two vectors when they are 90 degrees. Okay, so that's the rule for the adding two vectors. Okay, so now in this part, we're going to move into the little bit about the reference frame, because all the quantities that we are measuring will be always with respect to some frame. That frame, we call it as reference frame. Simple example is in all the measurements that we are taking on our Earth will be Earth reference frame. That means we're going to assume in that Earth is at rest. That will be our reference frame. We know that Earth is not at rest. It is keep rotating, but our physical quantities we are measuring by keeping Earth at rest, right? That's called it as the reference frame. But simple example I'm going to take here will say there is a train has the speed 100 kilometers per hour, and there is a person inside the train walking in frontward direction 5 kilometers per hour, right? So now when this happen, if you measure the speed of the friend with respect to the train, that means friend is walking inside the train, you are measuring the friend's speed with respect to the train. That means you basically keeping train at rest as your reference frame. Then the speed of the person will be 5 kilometers per hour, right? So now if you measure the speed of the train by keeping Earth at rest, but your train is moving. So with respect to that, train is moving 100 kilometers per hour, friend is moving 5 kilometers per hour, same direction. Then you need to add these two vectors. That will give you 105 kilometers per hour. You see, these two numbers are totally different numbers because you have different frames. So I want you to understand that we are measuring always physical quantities with respect to some kind of frames. Okay. Okay, so now let's move into our first physical quantity that we're going to discuss, displacement and distance. And physics, displacement and distance are two different quantities, right? Distance and displacement you can easily understand by using this diagram. If you move from A to B by selecting this blue path with the arrowhead pointing in B point, that is, we call it as the displacement. But if you travel to C and D and D come back to the B, that will be, we call it as the distance, right? Simple example, you can think you and your dog going to take a walk. You will take the displacement, but your dog will going to catch up the birds and come back to you. That will be the distance, right? So displacement is a vector, distance is a scalar quantity. That's the difference between distance and displacement, although both are measured by SI unit meters. Okay, so now we're going to move into the velocity. So velocity is defined as displacement divided by time, or we say that it is a rate of change of displacement. That is, we call it as the velocity. So now velocity and speed, again, two different things. Although we are using meters per second, speed is the distance divided by time, which is a scalar quantity. This velocity is the displacement divided by time. That is a vector quantity. So now your odometer on your automobile will give you a basically distance, right? That means speedometer will give you the speed, not the velocity, that kind of thing. Okay, so now it is very easy to understand by watching the graphical representation of the motion. First thing you need to understand when you see the graph, what are the axes of the graph? In here, you see that you are plotting position as a function of time. That means you travel 2 meters, kilometers 3, and then you come back again 3 kilometers, by time take 0.5 hours. That kind of behavior is there, right? But velocity is rate of change of displacement. What that means? That means it will be the slope of the position as a function of time graph. So now slope of the left side, this is, you see that here, uphill, that will be positive slope, and this is downhill, that will be negative slope, but they are constant, right? Because of that, if you take the slope of this plot, you're going to get the velocity plot that will be looks like this. You can calculate it and see, but important thing is this first part constant and this part also constant, but second one is a negative value. Okay, and so now instantaneous velocity is little different from the velocity. Instantaneous velocity means velocity at very small time interval, or velocity at that instant. We call it as instantaneous velocity. right? So it's very easy to understand by watching this diagram. So I have velocity as a function of time here. So now instant velocity means at 0.1 hour, I have velocity 40. That is called it as instantaneous velocity, right? So now since this graph, I have constant velocity, your instantaneous velocity for each time will be the same. That means average velocity will be exactly equal to the instantaneous velocity. But if you go to the right graph, this has change in velocity. When you have change in velocity, you can see at 0.1, I have velocity around 50, but when you go to the 0.4 hour, I have velocity around 20. Those are instantaneous velocity. In that case, my average velocity is different from the instantaneous velocity that I have it in different instant. Okay, so that's the difference between instantaneous velocity and velocity. Usually instantaneous velocity is the velocity that we are talking. If it is the average velocity, we need to use the average prefix to explain it is average. Otherwise, usual notation that used for velocity, acceleration, and displacement are instantaneous values. Okay, so now next one is acceleration. So acceleration will be change of rate of velocity. So then I talked about the displacement, velocity, acceleration. I just want you to understand those connection of these three things together. So now acceleration is change of rate of velocity. That means if you take the units, you will see that velocity units is meters per second, and you're going to divide another second. That means you're going to get the meters per square second unit, right? Acceleration means basically you are speeding up, or you have a negative acceleration. That means you are speeding down. So that is what the acceleration means. You should have change of velocity. So you can think in this example, I have 0 velocity, then I have 15 kilometers per hour after 1 second. Now, if I need to calculate the acceleration, you need to take this v value minus this v value and divide by that time. That will give you the acceleration, right? Sometimes you can have negative acceleration. You start with 15 meters per second, but you decrease the velocity into 5 meters per second. Now, we final minus initial divide by time will give you a -2 acceleration, right? That can have the negative direction of the acceleration. Okay, so now acceleration also have instantaneous acceleration, and also it has graphical way of describing that. If you take the slope of the velocity versus time graph, that will be the acceleration. Now watching here, you have velocity as a function of time. So now here I have uphill. If you take the constant slope is there, that has positive acceleration. This one does not have the slope, 0 acceleration. This one has downhill, constant acceleration, but it is a negative. So now you can see your acceleration graph accordingly. Okay. Okay, so now let's move a little bit into the graphical analysis of your physical quantities, because it's very important in physics. Most of the time you draw something and you need to analyze it. So then you need to understand what is this drawing represent to you. So first thing is you need to identify your x and y axis. X is your change in variable and y is what you're going to calculate according to x, right? So now your plot can be linear plot, it can be parabolic plot, power series, whatever kind of plot you get, you need to explain your physical variables accordingly. So now first start with the very simple one, linear. So now if I have a linear plot, if I need to find the slope will be basically you choose in 2 points of your graph, and then you measure the height, this rise divide by the run. So now how do I calculate the rise? Rise means this distance. That means you're going to use your y coordinate. That means your final y minus initial y, y2 minus y1 will be your rise, right? So now run is working with x coordinate. Then you're going to take x2 minus x1. That means this distance will be the run. So then you can calculate the slope, right? But when you go to the laboratory, we're going to use the software, Microsoft Excel or any other software, graphical software that we can use to plot those things. And then that plot, we can put it into the curve, linear curve, and then it will display the equation on the chart. When it display the equation on the chart, so your linear equation will be something like this: y equal mx plus b. So now this b is the y-intercept that may be related to one of the physical quantity that you are using in the laboratory, right? M is the coefficient in front of the x, that will be the slope. So that will represent another variable that you need to describe in your experimental setup. So now this will be important that you know how to identify those things on your equation on the chart. So now your plot can be uphill, as we know it is a positive slope, downhill it is a negative slope. If it is a horizontal line, slope is 0. If it is a vertical line, slope is undefined. So we already know those things. Okay. So now this picture, I want you to understand a little bit about the motion of the connection of velocity acceleration, right? So red arrows represent velocity, purple arrows represent acceleration. Now in first diagram, I have the red arrows, same size, pointing same direction. What that means? That means it is a constant velocity. It's moving with constant velocity, right? So when it moving in constant velocity, that means there is no acceleration. In this case, acceleration is 0. That's why I don't have purple arrow, right? Like you use the cruise control in your car, that means you don't not accelerate the car. And then second example, you see that your red arrows is keep getting larger and larger, right? That means I am speeding up. When I speeding up with the constant rate, that means the acceleration is keep constant. Those all arrows are the same. That means acceleration constant. And in addition to that, you can brake your car. When you brake your car, you decrease your velocity. Because of that, you see, I still have constant acceleration, but in negative direction. So that's the explanation of this moving of the car problem. Okay. Okay, so now we're going to move into a specific problem, motion at constant acceleration. So when I see constant acceleration means, so you have to get some understanding relation between displacement, velocity, and acceleration. Constant acceleration means your acceleration is constant. And then what your velocity graph looks like? Then what's your displacement graph looks like? So that's the part that I'm going to discuss in here. So as soon as you know it is constant, it will be belong to this category. So now, since the velocity graph should be linear, it should look like this. And to have a linear increase in velocity, my position graph should be looks like this. That means if you have constant acceleration problem, that will be belong to this kind of visualization of the problem. Okay, so now we're going to move into very specific problem. Before that, let's analyze this little bit about this, how to calculate the slope and things. Okay, so now I have one part here, x0 to x1, part number 1, and this is second part, and this is third part, right? So all the times are in x1 is given. So now it's asking you to calculate the slope in each part. Let's do the part number 1. So slope equal, how do you find it? This distance divided by this distance is the slope, right? That will be x1 minus x0 divided by t1. So this, we already know that x1 is 5 meters, x0 is 0, and time is 3 seconds. So units will be meters per second. So now what the slope represent? Since it is displacement as a function of time, it will represent the velocity, right? And then moving to the second one. What do you think about the slope? Slope in this case will be 0 because x1 and this point x and this point x will be the same. There is no numerator. Numerator is 0 basically. Because of that, velocity is 0. And third one, you will see that you have here, right? So slope will be equal. Your final place is actually x0. Initial one is x1. Divide by t3 minus t2, right? So now this will be negative x1 is 5, x0 is 0. Divide by t3 minus t3 minus t2 is 8 minus 6 is 2 meters per second. Okay, that will be the velocity on the last portion of the plot. Okay, so now if velocity as a function of time given, then with the slopes that you calculate will be represent acceleration. Those things you need to understand on your side. Okay, so now let's move into the motion at constant acceleration. When I have a motion at constant acceleration, those problem we call it as kinematics problem. Kinematics problem means you basically talking about displacement, velocity, acceleration, and time. Those are the kinematics problem when you have constant acceleration. So now those equation valid again when there is constant acceleration, and it valid for x direction, y direction, or any other directions, right? So usually I wrote this equation for x direction. When it is in x direction, this x will be the x, right? If it is in y direction, this all the x symbol I have will convert into y symbol. Other than that, you use in the motion x direction or y direction. That's the idea. Okay, so this will be easily derived, but we're going to understand how to use it. So now, first thing is you need to understand these symbols. So we'll say I have I initial and final here. If I start at position xi and position x final, those are the symbols that I have xi and x final, right? If you have a velocity here, x direction and I, this is x direction and final. Those are the velocity symbols that I have here and here, right? And in addition to that, since this is x direction, you have acceleration towards x direction, right? And other than that, I have the time symbol. So now why I have three equations in here. Three equations are useful when you have a problem. When you go to the advanced level, you need to solve three problems, three equations, linear equation to solve or find the final answer. But in your class, at least at one time, you have to use one equation. Simple example, if you know the one velocity, if you need to find the another velocity, if you know the acceleration and time, then this equation is the best solution, right? But if there is no information about the time, then this equation will be useful. If you need to find the displacement, then probably this equation is useful. That way you need to identify which equation to use in which problem. Okay, so now first problem we're going to think is free falling object. Now free falling object means basically object moving freely under influence of gravity, but no other disturbances. Those objects, we call it as free falling. Maybe falling down, maybe going upward, it doesn't matter if object is moving with that influence of gravity or that constant acceleration. Those problems, we call it as free fall motion. Okay, so now in free falling objects is basically we have constant acceleration. That acceleration is equal to y direction negative 9.80 meters per square second. Those problems we call it as free fall motion. Okay, so now there are a couple of things we need to understand. If I say object is drop, that means initial velocity is 0. If I say object drawn downward to upward, then you have initial velocity, right? So according to that, we need to use the formulas. Okay, so now what is important thing in happen when you drop the apple, if you take each same time interval, you're going to observe some important thing in here. One thing that you're going to observe, your acceleration on this direction going to keep constant as we discussed. Acceleration in this direction is constant. That acceleration is 9.80 meters per square second, right? And but your velocities keep increasing in this direction, but linear increase, right? And displacement also increase, but that will be parabolic increase. Those are the three plots that I discussed beginning of the constant acceleration. Okay, so now a little more about this gravity stuff. So if I drop two objects at the same time, these two objects should be land at the same time if they are free falling, if there is no air resistance. But if there is air resistance, definitely it will slow down the motion. But problems that we're going to discuss in your class will belong to free falling. That means no air resistance. That means every object on the earth falling down to the earth with the same acceleration, independent of the mass, independent of the size of the object. That is called it as the gravitational acceleration. That number for everybody has this number. Okay, so you see that in vacuum, we are working with the vacuum that we're going to assume in no air resistance. Okay, a little more about this G value. This G value, we're going to take it as a constant. Around New York, it will be 9.80, right? But it will change with the altitude. It will decrease with the altitude. That means if you go to the Denver and you have less gravity than the New York because it's a mountain area, right? And also G is varying with the latitude, and also it is a constant that we all have. We're going to assume in your class into this number for all the problems. Okay, so now don't confuse with grams and G, because G we used for the grams earlier, but this G is not grams. Okay, it's the acceleration. Okay, so now you're going to do some problems in your recitation, but here I'm going to take a very simple example to start with. So we'll say I have object. This is where that object I'm going to drop. When I drop it, as soon as I said that, I know that velocity at that point is 0, right? So now we'll say this object dropped to this place, 2 seconds. I'm going to drop this object 2 seconds. After 2 seconds, my object is here. I need to find the final velocity at this place, right? And this is where you started. And when you started, it is better that you label your y direction. This is y direction is. And this point, we know that y initial is equal to 0. That's the origin that I'm going to select. Okay, and in addition to that, you already know that you have acceleration in y direction. That will be negative 9.80 meters per second squared. Okay, so now my question is asking you to find the final velocity at after 2 seconds. So now you need to think. Start from the first equation. Do you think you can use first equation according to given information? Yes, everything is known except y final velocity. But can I use the second equation? No, because there is no information about y final, right? No information about this one. There is 2 unknowns. And if you go to the third equation, this is unknown, right? And then it does not have the v final. Not what I need to find it out. Because of that, none of these formulas will work for the question I'm asking. So now v final, I will be able to calculate by using the formula. Make sure you rewrite the formula into your problem, original formula first, and then plug the things that if you have something 0, make sure you make it 0 immediately. And then y final will be equal to ay. There is no time square, just time, ay and time. And then you're going to plug the values. Okay, so this will be equal to negative 9.80 times 2 seconds. So that will give me negative 19.6 meters per second. That will be your final answer. All right. So now, if I ask you to find displacement after 2 seconds, so now I'm asking you to find the displacement after 2 seconds. So now y final is the one I need to find it out. Now, which formula is best? Time is given, then you need to go to this formula, right? Then you're going to plug that into here, right? Original formula, v by I time plus half acceleration y direction and time to the power 2. This is, we already mentioned 0. This is also we mentioned 0. That means this equation will be half acceleration y and time squared, and then y final you will be able to calculate by using given information and time squared, right? So now this will give you y final, so y final equal, it will give you again 19.6, but units in meters, right? So that's how you solve the problem. So only important information, after every second, your velocity is increasing amount of 9.8 meters per second, but displacement is not like that. Displacement is a parabolic behavior that does not have that kind of relation. You need to write the equation and solve it. Okay, so all the objects that fall in are not belong to free fall. If there is an object falling with the some disturbances like air resistance, then we need to consider that air resistance into the object. Those we call it as non-free fall motion. So when there is non-free fall motion, what is basically happening is your object is keep falling, right, with the air resistance, right? What will happen is your object is falling, then your air resistance build up opposite direction. Because of that, your object going to be slowed down, and then after some time, these two going to be equal to each other. Then there is no acceleration. It will turn to acceleration 0 after some time. When it turns to acceleration 0, there is a velocity of the object. That velocity we call it as terminal velocity. So then object will travel with the terminal velocity without speeding up. So that we call it as non-free fall motion. What will happen is it's going to be slowing down, then sometime your acceleration going to be 0, then object will fall down with the terminal velocity. So skydivers jumping from the sky follow the non-free fall motions. So now I think I'm going to stop here, and that will be non-free fall motion, and it is a weightlessness features that we're going to come back and discuss again, drag forces and those things later. But important thing is it will slow down, speed is increase, but after it reach acceleration 0, then it's going to be falling down with the terminal velocity, constant velocity, no acceleration. Okay, so now make sure you attend the recitation and complete the work, and also submit your homework to get more understanding of the section.